Okay, so this is the dividing decimals video, and much like with the multiplying, the process is the same. We just have to account for the decimal point. With the multiplying, we accounted for the decimal point at the end. Here, we're going to account for it first. So, decimal point's right there. We're just going to bring it straight up. Okay? And then, we don't have to worry about it. We just divide it now as if this was 84 divided by 2. Same process, but now we have that decimal point up there that will, it changes the value. So I ask myself, 2 go into 8? Yes. How many times? It goes 4 times. And it's very important that you put the 4 above the 8, okay? Because we need to keep the decimal point in its correct location and keep that 4. That 4 is in the ones place here. So we need to keep it there. 4 times 2 is 8. 8 minus 8 is 0. Drop down the 4. 2 goes into 4 2 times. Since I'm dealing with that 4, my 2 needs to go here. 2 times 2 is 4. So my answer is 4 and 2 times. If you want to check it real quick, you could do 4.2 times 2. Okay? Let's take a look at example 2. And there's just another thing that we need to consider here within example number 2. Okay? We're getting to the point of the school year where we're taking what we know and we're adding to it. Okay? So there's a little bit more that you have to keep track of than you might be used to on previous grades. So make it harder, but you do have to concentrate. Okay? So like I said, let's keep track of that decimal point. Okay? And we just, 12 go into 6 now. So I can put X there above the 6. Can 12 go into 65? Yes. Now I know that 12 times 5, hopefully you don't have to do a 12 factor over here, but if you do, it goes 5 times. I have to make sure that this goes right here. 5 times 12 is 60. 65 minus 60 is 5. Drop down the 4. Okay? 12 go into 54. Well, how many times? Well, 5 is 60. We go 4. 4 times 12 is 48. Okay? Do the subtraction here. 14, that would be 6. Okay? This is where you would normally have finished. Okay? But this isn't a decimal, this isn't going to be 54 hundredths, remainder 6. Okay? We're going to take this one step further. How can I get another place value on this number?
Dave Snyder, please come to the main office.
We're 2 for 2 on the videos with announcements today. How about that? So, how can I get an additional place value without changing the value of the number? Well, now we have to pull what we did with the adding and subtracting and with making equivalents. Okay? I can add a 0 here. Did not change any of the place value. I can drop that 0 down. Okay? 12 can go into 60 how many times? Well, we can go 5 times. 5 times 12 is 60. Okay? As you get older, and you'll see in math class when we're doing the baseball that some of these will go on forever. In that case, we'll have to make a decision to stop it. But here, we have that option to add the 0. It does not change the place values. And we're going to be doing some work with that, with the baseball activity. Okay? So that, if there's going to be one that might give you a little bit of trouble, it might be that one. Okay? Example number 3. 4, 5, divided by 5. Okay? Put my decimal point. 5 going to 1. No. 5 going to 14. Yes, how many times? Well, that would be 2 times. Make sure my 2 is above the 4. 2 times is 10. 45. 5 goes into 45. 9 times. 29 hundredths would be my answer. Okay? And then the last one. Okay? Take care of my decimal point. Now I don't have to worry about it for the rest of the problem. 12 going to 1, no. 12 going to 14, yes, 1 time. 1 times 12 is 12, that's 2. Drop down to 5, goes twice, make sure it's in the right location. It's 24, okay. That's 1. Down to 8, you can only go once. It's 12, 18 minus 12 is 6. So like I said, we're not going to put a remainder. I have a decimal point. We don't use remainders when I have a decimal point. What can I do? I can get an extra place value without changing it by adding a 0 and dropping it down. 12 goes into 60 how many times? Well, it goes 5 times. So my answer would be 12 and 1500. Okay? So, keeping track of the decimal point and getting a decimal answer that does not have a remainder is a little bit different. But if you think about it, it makes absolutely perfect sense from what we've learned so far this year. We're just taking it to another level. Again, watch both videos. See me if you need some help. We'll take a quiz on this on Tuesday. And this is going to help us do the Plan the Party project that will be given next week.